This is part 2 of our probabilities using counting methods videos. Okay, so here's our new example. So let's say we had a bowl and it had 20 balls that were numbered 1 through 20. So all of them were different. We're going to select 3 at random. And what we want to know first is what's the probability that all 3 of them have an even number? Okay. So let's first consider, well, how many of the balls have an even number? Well, if there's 20, half of them would be even, half of them would be odd, so that would be 10. So we're selecting 3 of the 10 even numbers, so that's my event, and it goes on top. And then my sample space is there were 20, and I'm selecting 3. So putting those both into my calculator, I can see that 10 choose 3 is 120, 20 choose 3 is 1,140. Dividing those two, I get 0.105, which turns out to be 10.5%. So let's stay with this idea of the numbered balls in the bowl, and this time let's find the probability all 3 of the numbers are greater than 12. Okay. So start with greater than 12 does not include 12, so it's everything after 12, so 13, 14, 15, all the way up to 20. So that would be 8 balls. All I did was 20 minus 12 is 8. So 8 of the balls are greater than 20, and I want to select 3 of them. So I start on top again my event. I'm choosing from these 8 balls greater than 12, I'm choosing 3 of them, and I stick with my sample space 20, choose 3. So now in the numerator I have 56, same denominator as before, and that reduces to 0.049, which is 4.9%. Okay. So let's do one more with this idea of these numbered balls in the bowl, but I want you to try it. And then check your answer. So I want you to try to find the probability that the 3 balls drawn are all less than 7. Pause it. It should only take you a minute to do it, and then come back and check with me. Okay. So once again, we have to start with say, well, how many balls do we have that are less than 7? And that would be 6. We don't include 7, so 1 through 6. So I have 6 numbered balls that are less than 7, and I'm choosing 3. So 6 choose 3 says there's 20 ways to do that, out of the 1,140 ways to choose 3 balls from this bowl. Dividing those two, I get 0.018, which simplifies to 1.8%. I don't know if it's really simplifying, it's just stated a different way. I like percentages. I think you guys really wrap your head around percentages in a way that you don't wrap your head around fractions. All right, so I'm going to start this way. I'm going to say we have a deck of 52 cards, and we're going to be dealt 5. And I want to know the probability that all 5 cards we get are black. Okay, so most students tell me I don't know anything about cards, so here I am to help you. I have a picture, and then we're just going to go through some basic card facts. So there are 52 cards in a deck, and they're really divided into 4s by suits. So you can see them right here. I have hearts, I have diamonds, I have clubs, I have spades. So if I divide 52 by 4, that tells me I have 13 of each one. So the 8 kind of works like a 1, and then I count 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the 11, 12, 13 are Jack, Queen, and King. Okay, so I have 10 cards that are kind of numbered, and then these 3 at each one with a face. So 4 different suits, 13 of each kind. You can see here that the clubs and the spades are black, and the hearts and the diamonds are red. And then just these Jack, Queen, and King have people on them, so we refer to them as face cards. In case that comes up in any of your questions, so you know the ones with the faces, those would be the face cards. All right, so let's go back to the question I asked you. Let's find the probability that we get all black cards. All right, so I need to know how many ways could I get all black, and then how many ways could I just get 5 cards. So there were 26 cards that were black, and we're choosing 5 of them. There are 52 cards in the deck, and we're going to choose 5 of them. So 26 choose 5. This is 65,780. Sounds like a lot until I look at the denominator of how many ways could I just get 5 cards. This is 2,598,960. So this says these two together comes out to be 0.0253 or 2.53%. So it says it's really unlikely that this is going to happen, but even as unlikely as it is, it's not a winning hand. Getting all black gets you nothing. So let's look at something that is a winning hand, which would be a flush. So what a flush does, instead of looking at what color it is, it says what suit is it. And so a flush is all cards of the same suit. So I could have all hearts, all diamonds, all clubs, all spades. Just to break this down and make it easier for you, let's start with just clubs. Okay, so any other thing that would be a flush too. If I had all hearts, that's a flush as well. But I just want to make it easy, and I said let's pick just clubs. Okay, so if I just pick clubs, I need to go how many ways can I get 5 clubs? How many ways can I get 5 cards? So I know there are 13 clubs, and I'm choosing 5 of them. And then I'm always comparing it to how many ways could I just get anything. So 13 choose 5 gives me 1,287. But remember, I'm dividing by this big number, 2,598,960. So that comes out to 0.000495, which if I make that a percent is 0.0495%. So we went, getting all black was about 2%, getting all clubs isn't even 0.5%. So let's go back and talk about this percent and this decimal really quick. When I put 1,287 over 2,598,960 my calculator, what it put on the screen for me was 4.59 e to the negative 4. I want you to try this in your calculator too as a comparison. So if you have to stop me from talking right now, push pause and check this out because I want you to see what it looks like so you're not surprised later. This is scientific notation. So what the negative 4 means is that this first digit is 4 to the right of the decimal place. So when I go to write it down, and let's write it down for you, what I would do is I would start with a point, and then I would say 0, 0, 0. Then this 4, 9, 5. And what I'm counting is there are 1, 2, 3. This is the 4th number. Coincidentally, there's a 4, there's a 4. They have nothing to do with each other. This negative 4 tells me how many places to go to the right. This 4 tells me the number to put in, so don't let that bother you. I do know for some people this is something you haven't seen in a long time. Some people might tell me they've never seen this before. I don't know if you've never seen it before, but it may just be out of your mind right now. So what I did is, if you go back to my HTC, under these videos, I put in a link to a YouTube video on scientific notation, just so if you needed a review, you would be provided one. I didn't make the video because I could find too many that were easily accessible and were pretty good, so I just threw one of the ones from YouTube up there for you guys to check out if you need the review. If this makes sense, then don't go watch it. Okay. So let's check this out just a little bit farther and say, let's just find the probability of getting a flush. So the last example I did was find the probability of getting all clubs. But a flush would also be, they could be all spades, they could be all diamonds, they could be all hearts. They all have the same probability. They would all have the probability of 0.00495. So since I have 4 of them, I'm just going to multiply 4 times 0.000495, and it says 0.00198 or 0.198%. Do you see that getting a flush is really unlikely? This means it's a good hand in poker and will usually beat the other hands being played. So if you play poker, alright, so let's get away from cards. Alright, and let's look at winning a prize a different way and just say that I had envelopes. So here you can see I have 8 envelopes, and let's say they have prizes inside. So 3 of them have $500 and 5 of them have $1 inside. And we're going to select 2 at random. So I want you to try these 3 and then come back and check. So first I want you to try to find the probability of not getting either envelope with $500. You're picking 2 and you don't get the $500. Then I want you to find the probability of getting both of the cards that have $500. And then I want you to find the probability of getting at least one of the cards that has $500. Okay, this may take you a little bit, so pause the video, stop it, whatever you need to do. Try these 3, then come back. Okay, so let's just start with A. Find the probability of not getting either envelope with the $500. So what I look at is we're picking 2, and when I pick these 2, they're not going to have $500 in them, so I'm looking at the 5 envelopes that have $1. So from these 5, I'm going to pick 2 of them. So 5 choose 2 gives me 10. And I just compare that to how many ways could I pick 2 from the 8 total envelopes. So there are 10 ways to get something that's not $500, and there's 28 ways just to pick 2 cards. So it says there's a 35.7% chance that you could pick 2 cards and not get $500 in either one of them. Okay, maybe something we'd really want to happen is, well, what's the probability that both of them had $500? So that sounds good to me. I'd like to have $1,000 just from picking envelopes. So let's see what happens. There are 3 cards that have $500 in them, so we want to pick 2 of them. So 3 choose 2 is simply just 3. And again, I'm still over my 8 choose 2, which is my sample space. 3 over 28 gives me 10.7%. Okay, and then the last thing I asked you is find the probability of getting at least one of the $500 envelopes. So here again is that phrase at least, and anytime I see at least, I think let's do the complement. Okay, so the complement says look at the opposite and then subtract that from 1 or 100, however you're doing your probability. All right, so the opposite of at least one $500 bill is neither of them have $500. Okay, so hopefully you remember that our first question was find the probability that neither one have $500 in them. So that was 5 choose 2 over 8 choose 2, which we found out to be 10 over 28. So you could do it that way. You could do 1 minus 10 over 28, and it gives you 18 over 28, which is 64.3%. Or you could go back to what was your percent and subtract it from 100. As long as you're getting the same number that I'm getting, I don't care if you were using percentages or if you went to the combinations again. Math is fun in the fact that it has more than one way to do things. Okay, so let's look at another example, and this one I said selecting students. So suppose I have a group of 30 students in a class, and they happen to have 12 of them are business majors, 10 are marketing majors, and 8 are education majors. And we're going to select a group of 6 of them at random. I want to know the probability that 4 are marketing majors and 2 are education majors. And then B, I want to find the probability that at least one of them is a marketing major. Threw that word at least in again. All right, so let's start with picking 4 that are marketing majors and 2 that are education majors. Here's that word and I just want to make sure we go through words and make sure that we, talk about what do we do when they happen. So start with the marketing majors. I have 10 of them, and I'm going to select 4. Then I look at education majors. I have 8 of them, and I'm selecting 2. Anytime it says and, I want to multiply. So 10 choose 4 gave me 210. 8 choose 2 gave me 28. I need to divide that by how many ways can I do the sample space? So the sample space is there's 30 students in the class, and we're selecting 6. I want you to notice this 4 and the 2 add up to the 6, right? So that's important that these 2 numbers come up to be the total number I'm selecting. Okay, in the numerator I have 5,880. In the denominator I have 593,775. So that gives me 0.0099. If you wanted to, you could say that's 0.99%, or if you wanted to round it up and say 1%, I'd be cool with that. All right, let's go to the second part where it said find the probability that at least one of the people picked is a marketing major. Okay, at least, right? You should do this. Underline it when you see it. So at least means let's use the complement rule, which is the opposite. So what's the opposite of at least one marketing major? It means no marketing majors. Okay, so I know I had 10 marketing majors, which means the rest of the class, 12 and 8, that's 20. 20 of them are not marketing majors. Okay, so I'm not trying to pick a marketing major. I'm doing the opposite, which is no marketing major. So this is this 20, the 12, and the 8. And I'm going to select 6 still. So 20 choose 6 gave me 38,760. That sample space I had before, I still have it again. Again, you guys are using your calculators to do it how you want to. You can put this in your calculator from here. You can make this a decimal first, whichever is fine. So here I got 1 minus 38,760 over 593,775. It gave me 0.9347, or if you want to, you can say 93.47%.